So today we're going to do a little bit of review. We're going to talk about reference parameters. We're still in the topic of classes. So we're going to do reference parameters, method overloading, constructors, constructors overloading, and there are some strange ways of doing constructor overloading. Well, at least they're strange if you're not a C# programmer. They look significantly different than the Java way of doing it. So for those of y'all who know Java and not C#, it will look a little bit different than what you've seen before. C++ has, something kind of similar. Let's go ahead and get into it. First thing we want to do is I'm just going to create an empty little class so that we can start playing with it. And guess we'll redo one of our animal classes. We seem to do this an awful lot. Why not? So I'm going to make a console application inside the same namespace as my program. I'm going to make this called critter. And we're going to make a couple of variables for it. Instance members. The critter has a species. The critter has a name. So like Bob the dog, something like that. And we're going to implement a property, that returns these two things. So the general convention for C# programmers is to name their instance variables lowercase names and their properties uppercase names. So let's implement properties for both name and species, and then we'll come up with a third property which returns both name plus species. And so it won't be reflecting a particular instance variable like the others will be. Instead, it'll be returning something custom constructed on the fly, which is not stored in a particular instance member. Okay, so we want string name, and it's going to have a get and a set. Pardon me for sneaking a peek at my help sheet here. Alrighty, so we're going to write a setter and a getter. Get is going to, that looks very odd. I should put the curly braces. Yes. So get is going to use the curly braces to return this dot name. Let me get rid of the Solution Explorer over here so we have more room. And the setter is going to do set this name equal to the value that's passed in. While we're here, we're going to go ahead and create a constructor because we love our constructors. Constructor is a method that has the same name as the class. Public critter string name string species. This dot name equals name. This dot species equals species. There we have our constructor. I think we're going to create other constructors. We're going to overload it, but this is good enough for now. We have enough now to test it. So here is our critter class in its entirety as of now. Go ahead and pause it, make sure you can type it in, make sure you can compile it without error, and then you will be good to go. Alright, down in main we're going to create a critter. Critter squeaky is equal to new critter, and squeaky is a hamster. Now let's get the name of squeaky out. So console.write line, his name is plus squeaky.name. And in Java or your other languages, you would, capital N. In Java or your other languages, you would have used getName as a way to encapsulate your parameters. I'm getting an error here. Cannot be used. The get accessor is inaccessible. I didn't make string a public property, so I'm coming back up here and I'm making string a public property. I changed that inside my critter class. Public string name. All right. So name looks like a variable, right? But it's really not. Name is a pair of functions. It's a get function and a set function. Okie doke. Now let's implement a property which returns both the name and the species. So public string full name get curly brace return this dot name plus a space, so it'll say Squeaky the rodent or Squeaky the hamster, whatever, plus this dot species semicolon. This one doesn't even need a setter. So it's a read only. Let's see if that works. I'm going to scroll down here. I think I can close my output window to give myself a little bit more space. And I'm going to write out his full name now. Console.writeLine. His full name is, end quote, plus squeaky dot full name. Capital F, capital N. Rebuild. Start without debugging. Alrighty. I don't see the word the in there. I meant to put a the in there. But anyways, his name is Squeaky. His full name is Squeaky Hamster. Good enough. There are also auto-implementing properties. An auto-implementing property is just one that combines the instance variable declaration and the property declaration all in one fell swoop. Wrong, but I can close this. Alrighty. So for an auto-implementing property, all we need to do is, we're not going to even create an instance variable for it. I'm just going to say public, every critter has to have an age, right? Age, public int age. And we're going to say, okay, I want my property to have a getter and a setter. And magically it takes care of creating an instance member, an instance variable behind the screen to support that property. Is there any real advantage to using a property like that, an auto-implementing property, than a variable like that? I would assume that this is to support the .NET framework. I'd have to look that up to make sure. It's been a little while since I've done .NET programming. Okay, so now down here, even though we don't have an age member variable, we can set the little guy's age. Squeaky dot capital A, AGE is equal to 5, 6, whatever. Okay, so we've covered properties, the get and the set, the constructor, the accessors. This textbook calls them all accessors rather than accessors and mutators, I believe. And we've talked about auto-implementing properties, so when we don't have to provide the bodies for them. And of course we demonstrated a constructor, a parameterized constructor. We can overload that constructor. We may want a third constructor that accepts, not only a name and a species, but an age. Also, we could just go here and give it a default value, right? But let's go ahead and go back to the PowerPoint. Whoopsie. And look at what they have to say. Okay, the this reference. I think we already understand the this reference. It's a reference to the current object in which we are in, and if you type this dot, then the IntelliSense will populate it with all the members, properties, and methods of the class. All the instance ones, not the class ones. Okay, so we've talked about constructors. A default constructor is one that is supplied by the compiler. It doesn't accept any parameters, and you can give your own non-default custom parameterized constructor where you do pass in parameters, and that's what we did here. So in our code here, if we tried, whoopsie, why am I launching Java? If we tried to create a critter without those values, so Fluffy the cat, critter Fluffy is equal to new critter, that doesn't work, because once you provide a parameterized constructor, the default constructor no longer is given to you automatically by the compiler. So we could go back up and we could add a default constructor. I'm going to leave that alone. Don't need to do that. So here they have an example of a class called employee. It has a constructor that takes a pay rate, and the pay rate will set the pay rate property that has a getter and a setter. And the constructor is not even setting ID, number, and name. Kind of interesting. So here they are overloading the constructor with different versions. One version takes an integer, which would be the int, the employee ID. One version takes the integer for the employee ID and double for the salary. And a third one takes a character for a code. Now these are overloaded constructors. Overloading is when you provide multiple methods that have the same name but different parameter lists. And the reason this works is they made all three of their properties have different data types, right? We have an int and we have a double, and then this last one is a character. Well, that's interesting. Okay, so character is some kind of default one that sets the ID, number, and the salary and doesn't even use that code. So I don't see the point of that. But anyways, how could you have, a constructor that would let you take two different things with only one parameter? They would have to be different parameter types. So Constructor Initializer is a clause that indicates another instance of a class constructor should be executed before any statements in the current constructor body. So you want to call a different constructor. Kind of like calling the, no, I'm not going to even make any Java comments. So here, we're going to say that the default constructor actually calls this constructor that takes two values. Let's go add that to our mouse class. Let's add a default constructor that gives, it's not a mouse class, it's a critter class. Let's go add that to our critter class. So we're going to go back up to critter, and along with this one, we're going to give it a default constructor because that thing was giving us an error when we tried to, call it that way. So public critter, no parameters, default, but when this constructor is called, call our other constructor with default name, end quote, comma, default species, or unknown name, unknown species, or whatever. So when the default constructor is invoked, because we didn't pass in any arguments into the constructor when we did the new operator, it will invoke this one, fill it in with the name and the species. We could prove that. Let's go down here. We were creating, this critter. Let's just comment this out. Nah. We can make a new one, but I'm going to wind up. I'm going to remake Squeaky. How about that? So I can just copy and paste those two print statements. Squeaky is equal to a new critter. We're not going to give him any values, any arguments. Now let's print these three things again. So I'm just going to copy and paste them. right? Highlight those 3 lines, copy, come down here, paste them. Let's give it a run. There are build errors. I wonder what they are. Oh, can't put a semicolon there. We're just going to give an empty body for the constructor.
I did the same thing.
Alrighty, so just for fun, let's put some console.write statements showing which constructor is being called. Console.writeLine, or yeah, writeLine, default constructor. And then do the same thing for the parameterized constructor. I'm just going to call that a custom constructor. It's the non-default one. So when we create Squeaky the first time, all it's going to say is custom constructor, right? Because we are passing in these arguments. The second time, we're going to see both the custom constructor called and the default constructor called. The order in which they are invoked is that this happens first before we enter the body of the default constructor. If we're going to parse shades of meaning, I shouldn't be calling it a default constructor at this point because it's actually doing something rather than nothing. But I'm going to continue calling it that. Just know that it's not really a default constructor anymore, but it's a habit of mine to call it a default constructor if it doesn't take any parameters. Okay, so what we're going to see when we create the one without any arguments is it's going to say custom constructor first, and then it's going to say default constructor. Even though it's invoking this one, the very first thing it does is it jumps down here, runs the other constructor, does all this stuff, then comes back and does whatever we have in here. So I'm running without debugging so that I don't have to go and add a read key to the bottom. Okay, so we called the custom constructor. His name is Squeaky. His full name is Squeaky Hamster. Custom constructor, default constructor. His name is default name. His full name is default name, default species. So this is invoking the other constructor. Are we good to go? So while I'm here, I'm going to go ahead and comment out my right lines. They just clutter things up, right? I'm also going to go ahead and add my read key to the bottom of main. Console.read key. All right, I've had people ask about the reference and the out parameters. So we're going to go ahead and demonstrate them. I think I'm just going to go ahead and put them in main rather than as part of the mouth class, the critter class. So I'm going to make one method. All of a sudden my brain is seizing on a valid reason to do this.
Oh, and I guess an add method where you pass it in. If you don't pass it in as a reference,
that can be changed. Right. Yeah. So we're going to do a method called divide that takes 2 ints and returns a true if the division happened, and it returns a false if the division didn't happen. And if it did happen, we're going to fill in a good value for the output parameter. So we're going to pass in int x, int y. We're not going to make it void. We're going to make it bool. And then this is an output parameter. So out result, but it's an int as well. Okie doke. Not all code pass return. Well, that's very true. Okay, let's check our error condition first. If y is equal to 0, it's a problem. We're going to return false because you cannot divide an integer 0 by an integer 0. But, all right, I have not assigned result anything, right? And it's complaining about that. If you put the word out here, we have to assign some value for it. I'm going to give it a default value of 0. So result is equal to 0. If the y parameter is equal to 0, we're going to return false. You know what, we can move that right here. I'm going to go ahead and put this inside here. If y is equal to 0, our result is equal to 0, which is not a valid value, they will have to check the return value as well. But if it's good news, if this does work, let's go ahead and perform our division. Else, result is equal to x divided by y, return true. By defining this as out, it does not require us to set an initial value. If this word was changed to ref, we would in fact have to have an initial value. And we'll write one more that does do that. But when we want to invoke this, I'm just going to write another one called static void test. I could put this in main, but static void test that is going to invoke that thing. So we need an output integer. I don't need to give an initial value. And then we need a boolean. So bool BOK is equal to divide 4 by 2, storing the result in the result variable, 4 comma 2 comma result. And we're getting a complaint. Int, out, int has some invalid arguments. Did I put the word out there? Yeah, okay. There we go. Had to put that there to match that. You would check BOK to make sure it's a valid value before you used it. You can have as many out or as many ref parameters as you want. So let's write one more method that takes a ref parameter. And we're just going to make this one called double. Nah, double's a really bad term. Cube. It's going to cube the value. Static void cube me. Reference integer x. And it's just going to cube that thing. So x is equal to x times x times x. Now would this work in a pass by value situation? In a copy situation? No, because x would just be a copy of the value. You could do anything you want to it, and it would not affect the argument that was passed to it. But by passing it in as a reference, we can use it. Well, let's go down here, and maybe we're going to cube our division result. And let's define something else. Int number is equal to 3. I'm going to leave that equals 3 off just to prove a point. And then I'm going to say cube me number. But since I have this keyword here, the ref keyword here, I have to put a matching ref keyword here. And this is going to give me an error, but we're going to correct it really quickly. The error is that if it's an out, you don't have to give an initial value for it. It doesn't give you an error if you do, but you don't have to give an initial value for it because it's assumed. We're kind of writing a contract to ourselves that we will fill that value with a valid piece of data on the way out, but that whatever we're passing in is not important. If whatever we're passing in is important, we use ref instead. So I just need to give this a valid value, like that. I have to initialize it before it'll work. So there we go. We've done reference parameters. We've done out parameters. I don't think I'm going to cover parameter lists again. Check the book for parameter lists, Google Online, C#, parameter lists. You can find plenty of examples there. All right, so we're good? You got that working?
Yeah, what I did was I just because along with our cube me method, I just made one called don't cube me. And I just passed in the regular X and did the same thing just to
prove that it didn't work. Okay, so yeah, if we were to do what Adrian just did here, static void don't cube me. That takes an X as an integer, and it does this. I've got something weird going on here. X equals X equals. Let's fix that. Alrighty, and then X equals X times X times X, right? So down here, I never printed out the value of cube me. Int num2 is equal to 3. Don't cube me num2. Let's print them out. Console.write line placeholder 0, placeholder 1, comma, num, comma, num2. And I never actually called the test method, so I'm going to go down here in the first line in main. It's just going to be to invoke test. So we'll see that the call to cube me worked. It modifies the value of the reference variable, but don't cube me does not, because it's not passed in as a reference. There we go. So 3 cubed is in fact 27.
So how do you get the result out of the Boolean one since you're not?
You store it in the Boolean. So when you call don't cube me, divide. If you print BOK, it'll be true or false.
Yeah. So let's go ahead and do that as well. We're going to.
But don't you want the result?
If you want both, it's like our try-parse.
Yeah, it's exactly like try-parse. So if BOK, we're going to console dot write line divide result equals placeholder comma result. But if BOK failed, if it's false, it means that the division failed, and we cannot trust the result. It will return a 0 because that's what we made it, but we should not trust the result. So console.write line divide failed, like that. So the first time I run it, it's going to say, that 4 divided by 2 is 2, so that's going to be the result. But if I changed, the denominator to 0, then we're going to get this message instead. So it worked. The divide result was 2, but if I come in here and I change the denominator to 0, divide failed. So that is a common strategy for using output variables. Is if it succeeds, you return a true. If it fails, then you don't trust the values of your parameters. Does that make sense, Kathleen?
Yes, I think it does. What were you saying? It was like
how we. Okay, so how in Java.
So one word of warning is that if you define a reference parameter or an out parameter, it actually has to be a variable of the same type. Can't be a constant, and it can't be a literal. Let's prove that to ourselves. Because what would it mean, if num was a constant? how could that cube me function change it? So const space int space num is equal to 3, and we're going to get an error there, right? Must be an assignable variable. Ref means it's a little contract with ourselves that the cube me function has full access to that variable in order to change it. And if we declare it as const, then it's not going to be able to change it. Same thing with literals. You can't say a reference to 3, right? Yeah, that is its own constant. How could you possibly change the value of 3 to 9, you know, like that? So you have to pass in a variable of the same type, and it can't be a constant. So using the read-only modifier in a constructor. If you put read-only in your constructor, assigns a value that cannot be changed. The value can be assigned at runtime rather than compile time. They can get their value from user input or the operating system. So here we go. We are making a member of the employee class read-only. It can be set with a property, but once it's set, nope. The number field cannot be assigned a value after constructor. So here we are setting ID number in the constructor, but we can't change it later. So we could show that. Let's go back to our critter class, and we're going to make age for whatever reason.
A blood type, you can't really change it.
Yeah, a blood type. Let's do blood type. That's a cool idea. All right. So for our critter, read-only string blood type. And we don't have any constructors that set the blood type. So why don't we add a, go down to our parameterized constructor, and we're going to pass in a blood type. String blood type, but we're going to go ahead and give it a default value. I don't know what the world's most common blood type is. I don't know if rats have the same antigens as we do, but anyways. A+. That's what we're going to say. And get rid of that semicolon. I'm going to format this a little bit differently so that it all fits. Okay, there we go. So we added a third parameter to our parameterized constructor. Now when we go and declare squeaky, we will not be able to change the value of this instance member even if we made it public. And if we do public like that, or we could make it a parameter. Let's go ahead and declare it as a parameter.
As a property?
Excuse me, a property. Yeah. So public string blood type, capital B, parentheses, get return this dot blood type. And if we provide a setter for it, it's not going to actually be a good thing, so I'm not sure why I'm going down this little rabbit hole.
It wouldn't let you do that, right?
Right, it's not going to let me do it. So I'm putting too many things in the lines here. Public string blood type, get return this dot blood type, semicolon. Set this dot blood type equals the value that's passed in. And it will not let me do that because blood type will have already been assigned. A read-only field cannot be assigned. So I would have to get rid of that. So blood type is in effect a read-only field. We could have already made it read-only, right, by just not providing a set. However, this is an even stronger enforcement. This means that no method in here can change the blood type. You know. So if some other programmer works on our code and they write a method inside our critter class that's going to change the blood type value, it will not work. We can prove that to ourselves. No, we can't, because we don't have any other methods that aren't constructors. So let's go ahead and go down here, and we're going to make our first mouse, our first critter, first hamster.
I do have a quick question.
Yeah.
Because I don't really remember it in kind of briefly. For enum, so say we wanted to have like our blood types at like a set, like just A, B, C, and D or something. I'm just not really familiar on how enums work.
Yeah, let's go ahead and do an enum for our blood types. But first, let's make sure this actually works.
Okay,
so, since we never implemented something that would convert this to a string, way down here when we create Squeaky, let's give him a blood type. I botched that. All right, back to where I was. Comma, he's a special hamster with a blood type of Q negative, whatever that means. Alrighty. So let's write out his blood type as a third thing. Console dot write line parentheses, his blood type is space in quote plus Squeaky dot blood type with a capital B. And I'm going to copy that statement and print it to the one that used the default constructor, right? So down here, I can print that out. And if I try to change his blood type, you know, it is a property, but if I type Squeaky, I'm going to delete this line so you don't even have to do it. Squeaky dot blood type is equal to 7, 8. That's an error. You can't do that. Because it is the property doesn't have a set method, and underneath it all, the instance variable that the property is exposing is set as read-only. So we should run it. Squeaky, his blood type is, it didn't say. His default name, his full name, his blood type is, okay, I goofed something. What did I goof? I am passing in a blood type there. Oh. In my constructor, I never actually use a value, right? Way up here, inside the critter constructor, I set this dot name equal to name, this dot species equal to species, but I never added this dot blood type equals blood type.
But would you have to do that if you give it a default value?
Yes, because this is just a parameter.
Okay.
We have to convert that parameter to a property or a instance variable type. All right, Squeaky's blood type is Q minus. The default hamster's blood type is A plus. And once they've been constructed, it cannot be changed. All right, let's look at enums. First, we're going to pause so I don't lead us astray. Different languages implement them slightly differently. So an enum, you use an enum to declare your own variable type that has a restricted set of values that it can be set to, a discrete set of values, and you define those values. So we're going to declare one called state, and it's going to be the state of the critter. And the critter's either going to be healthy, sick, or dead. Poor critter. All right, so enum, we're going to make it a public enum. I wonder if all enums are public. I don't recall. Anyways, public enum state. And then inside curly braces, we list our states. Healthy, sick, dead. And now that we have that variable type, we may as well declare a member that uses it, right? We may as well declare it as a property. Public No, because that won't give it a default value, will it? So let's declare it as a public instance member. Public state health is equal to state dot healthy. By default, our critter is healthy. So whenever we refer to one of these values, we have to prefix it with the name of the enum from which it came. Because, right, you could declare another enum that also had the word healthy in it, and you have to be able to distinguish between the two. So after we absorb this idea, we're going to scroll down and we're going to change the status of one of our critters to not being healthy anymore. So make sure you have those two things. Scroll down here. After we create our second default critter, let's try to set his health. Squeaky dot health dot, or squeaky dot health is equal to, and how do we get a hold of that enum state? We have to properly resolve it with the name of the class. Critter dot state dot sick. All right, there we go. So this is in effect a class member, the enum is. Not the health, that's still an instance member. But we had to refer to that by its class name. I wonder if you could refer to it by the object name. Nah. Alrighty. I also wonder if I make the enum non-public, if I can still change it down here. You don't have to make this change, this is an experiment, but I'm going to scroll back up to my critter. Take that out. Run it. And no. Okay, so if you want the enum to be exposed so that the calling code can use it, then you do that. And so what are enums for? You could write an if statement or a switch case statement that's based on it, and you're guaranteed that it's going to be only one of a couple of different values. Why are we getting an underline here? Probably because I haven't recompiled it. Yeah, good. Hate it when it shows an error that goes away just because you compile it. So in here, you know, public void, you know, whatever, print health, you know, we're going to switch on his health. So switch based on health, case state.healthy, console.writeLine. Yep, he's healthy. And why am I getting an error on this? Cannot fall through from one case to another. Well, I'm not trying to. Okay, but I haven't added a break. Is that going to make it go away? Yes, okay. Now let's add another one. For the other two cases, I'm just going to copy and paste to make this really fast. Copy those two, those 3 lines. So inside of print health, in our critter class, if he's sick, we're going to say, aw, he's sick. Aw, he's not feeling well. And the last cut and paste is if he's dead, state.dead, we're going to say, he's dead, Jim.
That's awesome.
All right. So now we have a print health method that we could go and invoke down in main. So we could do squeaky.printHealth, and it's either going to say, yep, he's healthy, he's not feeling well, or he's dead, Jim. All right. I think that's enough for this lesson. So I hope that was pretty clear. We covered things from, you know, this is a little bit of a review grab bag. So we covered stuff from prior chapters, but I hope that it hammered it in for some of y'all that had questions. And looking at your quizzes, there certainly were questions over some of the topics that we've hit here. Yes, ma'am. All right.
Hello.